Array, we're going to have an endpoint on one side. And then it's going to continue on in that one direction. Forever and ever and ever and always. So if I name that one point B, we do need to have another point that it goes through. So add one more point, doesn't matter where on your array there. Let's call that T. So up on the board, you can see that we have that workup from yesterday's warm-up still is on the board. So when we did a line, we did the line above it with the arrows. When we did a segment, we just did that line with no arrows. How do you think we're going to do a array? How many arrows does a array have? Just one. So we're going to say ray BT. All right, now the order we put our array in is really important because remember we talked about how it's a one-way highway. So can I write it as T going through B? Why can't I write it as TB? What would that tell my reader? That T is the starting point, and then it's going past B. Is it starting at T and going past B? Nope. So this TB doesn't work. So what I'm going to do is I wrote it, and then I'm going to just really lightly cross it out so I know it's wrong. But that's a common mistake that people do with arrays is they switch around the order. Arrays, the order really matters. You have to do the starting point first, and then where it's going. Now, array doesn't always have to just go straight across. We could start up here. Call that K, and then go in this direction. It can be diagonal. We'll do that KM. So these ones might be easy for us to name because we drew them. So when we drew them, we thought about the starting point and where it's going. But when you look at array, that's what you want to think, is when you name that array, you have to think, where is that starting point? How is that going to start first? So in this array, where would we start? K, and then it's going to go through M. Now, for some reason in math, just to keep it, not for some reason, to keep it consistent, we just can't have everyone doing everything all the time. Then we just have no rules and life is crazy and chaotic and we don't know what's happening, right? Some people, they're like, oh, well, if I do array this way, and I write that it starts at K and it goes past M, now we're just getting into the crazy business. That's insane. It's too much. So when we do arrays, we only use our arrow going left to right. We don't go backwards, only left to right. So if you need to make that mark, just remind yourself, we don't do it that way. We only go right to left, and then our beginning point and where it goes through. All right, woohoo! How we doing? Good so far? You guys excited? Yay! I'm just kidding, you're probably not. That's okay. All right, next up we got angle. Again, I'm hoping most of you have previous experience with angles. What's something that you remember about an angle? Any of you remember anything about an angle? Good. Obtuse, acute, the 90 degrees, the right angle. Remember that stuff? A little bit? A little bit? A little bit? Good. That's really what we're going to talk about today, so that's perfect. All right. So an angle is the space created by two rays that share an endpoint. Space created by two rays that share an endpoint. All right, now I'm going to be honest with you. After today, you are probably never going to look back at this definition for an angle. It's similar to like a four-way stop. Once you know what a four-way stop is, what is a four-way stop? And where are the stop signs? Where? Yeah, it's where they cross, and how many stop signs are there? Four. Once you learn that there's four stop signs, and somebody says, oh, there's a four-way stop, do you need to pull out your dictionary and look up what a four-way stop is? No, because you see them so often. Okay? Angle is like that. This first time you might look at it and be like, oh, that's an interesting definition. I never thought of it that way before. But once you know what an angle is, you don't really look back at that definition. You just kind of see it and you're like, oh, yeah, it's an angle. I get it. Okay? So as we do this, we're going to start with an endpoint because they share that endpoint. And let's call that endpoint M. I like using M because my capital M's look really good. I don't know if you guys noticed that. I use M a lot. Alright, this is where I'm going to take my colored pencil, and I'm going to draw a ray going from M out. So one ray that goes in one direction. Okay, we'll need one more point on that ray so that we can name it. So I'll throw one at the near where I drew the end of it, but just somewhere on that ray past M. We'll call that L. Such a good friend, Nick. Okay, I'm going to take my other color pencil and I'm going to draw another ray, but that ray needs to start at M. So I'm going to just start at M, and I'm going to work my way down this time. If you're not a colored pencil person, that's okay. We're just going to color code a couple of things today. So if you don't want to color code, it's your choice. But, I don't know, makes your notes look more interesting, I think. It also helps me realize what parts go with what. And let's name that X. So we're using those capital letters for those points. Points always get capital letters. That's going to be maybe on your test at the end of this chapter, that points have capital letters. All right, and the angle, though, is actually the space created by that. So our angle is actually this amount of space that is created by that opening. So when I say angle, we're not necessarily looking at from M to L or M to X. We're looking at that opening that's created between those two rays. All right, if Mr. Kwan goes over to the door and he shuts the door, not all the way, right there, stop there. Is that angle, we're looking at that space. Is that a big enough space for Mr. Kwan to walk through? Yeah, walk through that angle, Mr. Kwan. Thank you, perfect. Now, if we shut the door more, can he now fit through that angle? That space? No. Well, unless you have superpowers. You like Mr. Fantastic? No? Shoot. Alright. So that angle, we're really looking at that space that's created. Okay? So a couple of things about this is we need to know our name. In geometry, names are important. Now, when we name an angle, we're going to use a symbol, similar to how we've been using these symbols for rays or lines. This time we're doing angles, so what we do is we make this little angle sign. And then we're going to outline our angle like in one smooth motion. So if I start at L, where would I go next after L? M and then to X. So we could say angle L, M, X. Okay, so as long as I can outline it in those letters, that's the way it works. So instead of starting at L, what other point could I have started at? X. If I start at X, which point would I go to next? M, and then L. Good. X, M, L. Could I do MLX? No, if I do MLX, that's implying that L and X have a ray connecting them. And then we're looking at the in-between there, which isn't there. So those are the only ways we can do it with letters. Sometimes, though, you're going to see a number in the middle, like a very small number. So let's call this angle 3. We're going to put a little 3 there. And you would see that when there's lots of angles in the picture or there's too many angles to really put points in every part. So if there's a little symbol there, we would call that angle 3. If there's a number, we can also call it angle 3. We use a mix of those. Sometimes we do it with the points, sometimes we do it with the number. All right, now there is a very special point in this angle, and that is a vertex. Okay, we learned that word vertex in algebra last year when we worked with like parabolas or we worked with absolute value functions. Do you guys remember when we worked with the parabola, that U-shaped graph? What was the vertex? The top, or if it was like a U, the bottom. It's where like it came together at the bottom or where it came together at the top. So a vertex is like that middle point. So it's in the middle. Or you can think like where that angle connects or comes together. And it's one point. So our vertex here is what point? M, good. Now, an angle is also created out of sides. Kind of those sides, if you think of a shape has sides. An angle is almost like a shape, not quite. It's more of a space. But that space is confined by the sides. So sometimes we're going to ask ourselves, what are the sides? And when we look at sides, really what we're looking at is what are the rays we're using. So in our angle here that we created, what's one of the rays, one of the sides of that angle? Good. L is a point, though. We want a ray. So where does that side with that L, that red side, where does it actually start? M, and then it goes to L. So the red side goes M to L. For me, it's red, so I'm going to use that red there to remind myself that's what I'm talking about, is that red side. ML. I need to sharpen my red pencil. Does anyone feel confident that they can name that blue side for us then? Good, we're going to use X. We need 2 letters though. Good, on that X, it starts really where? It starts at M and then it goes past X. So we're going to start with M. I can't find my pencil. And then it goes to X. These are arrows above. My pencils aren't very sharp, so they look a little messy. So we have our red side and then our blue side. And that's what comes together to create that angle. All right, we have about 2 minutes, so we are going to continue this tomorrow. These were just like our basic words. Tomorrow we'll finish the notes, and then we'll have homework on this. Okay, so if you can clean up your spots, if you can put your colored pencils back in that bag, it really helps my next class to find their colored pencils. You should know that when I say like a 360 degree, you should know what that means. So we're going to just jot those down just to make sure that we're all on the same page with that. So what does it mean if you're going to do a 360? Good, a full circle. If I do a 360 right now, let's turn around, right? We do that like in snowboarding and wakeboarding, skateboarding, all that good stuff. We say do a 360. Okay, so 360 is all the way around a circle. You're going to do a full turn. All right, we also have a 180. What is a 180? Good, a halfway. So if I'm walking in one direction, if I'm walking in a straight line this way and I make a 180, what's going to happen if I turn around? Yeah, I'm going to keep walking, but on the other way I came from. Good. So this actually looks like a line. If I'm walking in this direction, I make a 180. I'm now going to walk in the other direction, and it creates a line. So I hear Miss Freeze do that a lot, where like if somebody's walking somewhere and she wants you to stop walking, or like you're supposed to be in class, she says, "Whoa, stop, make a 180." And she wants you to turn around and walk the other direction. All right, what's another angle that most people know? We already talked about it today. 90. Good, so 90 degrees is kind of that L shape. And there's a marking we use for all 90 degree angles.
That's the square in the corner.
Good, we make that little square in the corner, and that tells our reader that even though we just hand drew this, if it's not exactly 90 degrees, that's what we wanted it to be. Now we know for sure, yep, that is a 90 degree angle. Okay, and then our last one is going to be a 45 degree angle, and that one we're going to imagine a little bit. So I'm going to start with that line going across. 45 is half of that 90, so I'm going to imagine in my mind kind of this 90 degree going straight up. And then for 45, I want to cut that kind of in half. I want to bring that down, cut it down in the middle. So 45 should be one that you feel comfortable drawing. It should be one that you can kind of imagine what a 45 degree angle. It's like 90, but then half of that. Okay, so that's that 45 degree angle. All right, we're going to draw angle BKM Remember, for angles, we use that little angle sign. Just like a little L almost. A little closed. We use an acute angle there. BKM. So that the measure of angle BKM equals 78 degrees. So you put a little m here in this part here, and that tells us that that means measure. Okay, and the way that we would say it is like measure of angle, BKM. So if you need to put a word of there to remind yourself. But that M tells us that we're actually measuring it. We're saying how big is that angle? How wide does it open? All right, so when we draw this, we're going to think 78 degrees. And I'm going to think back to these main degrees. Where would 78 lie between? It's between the 90 and the 45. So we know it'll be a little bit more open than the 45. Should it be closer to the 90 or closer to the 45? Good. It's going to be really close to that 90, but not quite to that 90. So when I draw that, I'm going to have that line going across. I always start with my lines there. I'm going to think the 45 is here. My 90 is here. I kind of lightly like to draw in those little lines so I know where they are. And I know I want to go to 78, which we said was closer to 90. So I'm going to draw it a little bit more open. Now we didn't use, it's called a protractor. Okay, a protractor is what's on my floors outside the doors. Okay, those blue things. Those actually you can use to like actually get the right degree. The exact. So because we didn't use a protractor, we didn't use that, and we set down to get the exact 78 degrees. We're going to tell our reader it's 78 degrees by writing that in the middle. And making sure we have that degree sign there. If you forget the degree sign, then we might think it's an angle name. Remember, angle name, we can use that like 3. Then that would be angle 78. But since we put degrees there, that tells us it's a measurement. Now, last thing we need to do is we need to write BKM. So I need to label those points. So we have our point in the middle there. What's that special name for the middle point of an angle? Vertex. Yep, you got it. Sorry. 1 second, Tommy. We'll get there. And then I also have points on our sides. Now, when we named an angle, we wanted to make sure, I'm going to come back down in just a moment. Yesterday when we did this, we did LMX, or we could do XML. But it had to go kind of in that order. And that middle point, that M, went in our middle position. So if I look at BKM, which one of those points has to go in the middle? Which one is our middle point? K. So K has to be the vertex. Now it doesn't tell us enough information about B and M where those have to go, so they could go in either position. But K has to go in that middle because it's the middle point. So I'm just going to go B, K, and then M. All right. So next up we have angle bisector. Not angle bisector. I lied. Congruent angles. Congruent angles. We've talked about that word congruent. We talked about it with segments back in 1-2. I think we talked about it. What does congruent mean again? That they're the same or that they are equal. So congruent angles are angles with the same measure or with equal measure. Alright, so if I draw two angles here, we'll say that's maybe a 50-degree angle. And we'll just keep it simple. We'll call that angle A, B, and C. Alright, and then if I have another angle over here, that's maybe going this direction. Doesn't have to be going in the same direction. It doesn't have to look like a copy and paste. But again, if I put 50 degrees there, now I know these are the same. And we'll call that one M and P. Oh. Alright, so what are some ways that I can show that things are congruent or things are the same? What? Yeah, tick mark. When we did a segment, we did tick marks. Now, with angles, we don't use tick marks because they're not the segments. What we're going to use is these little arcs. So if you want to use a colored pencil to show, these arcs are going to be the important part. This little arc here. We go from that A to that C. And then we're going to measure or keep that with that arc near that N. And that tells us that these match. Okay, we could use one arc. Sometimes we'll use two arcs if there's multiple angles. The number of arcs you see in those corners tells you which ones match. So now we know these match. And then we can also use that symbol. So we would say angle. Who feels like they can name this first angle for us? A, B, C. Good, we're going to use those three letters, A, B, C. B is in the middle. That tells me it's the vertex, it's the middle point. And then it goes out to A and it goes out to C. What's that congruent symbol again when we write it? Good, an equal sign with that squiggly top is congruent to angle. Who's got a name for this other angle for me? Can you say that again? NP?
No, M.
M and P. Good. That's what I thought you were saying, and then I kept missing the N. M. M and P. So N is our vertex, so N goes in that middle spot. Alright, I'm going to be going to the next page because I'm out of space. So if you need this, make sure you get it written down. If you still have room on your page or you already went to the next page, just keep going. We got a couple more things here. I know it feels like a lot today. That's why I broke this up into 2 days, because it's just a lot of basic information, but important information. Okay, perfect. Alright, next up we got angle bisector. Again, we heard that word bisector already. We heard that with segment bisector. So an angle bisector is similar What did it mean to bisect something? Remember, bisect has that prefix bi, which means how many parts? 2 parts. Okay, so a bisector, an angle bisector, means it's going to cut in half. What is it cutting in half? An angle, because it's an angle bisector this time. So something that cuts an angle into 2 equal parts. It could be a line, it could be a ray, it could be a segment, it could be a plane technically. Oh, you can't see that. There we go. Alright, so if I know that ray JP bisects angle TJM, and I want to draw that. Alright, what we're going to start with is we're actually going to start with that thing that we're cutting in half. Like if I tell you to cut your pencil in half, do you just start with half a pencil? No, you start with the full pencil and then you cut the pencil in half. So what is my full thing that I'm cutting in half? Yeah, the angle. So if you want to take a colored pencil, you can. You don't have to. If you don't want to, it's your choice. Colored pencils are fun though. Okay, if I have angle TJM, I'm going to start with that. I'm going to draw an angle that looks like this. So if you can draw one similar, that'd be great. If not, that's okay. So I'm going to start with that angle. That's my full thing. TJM. Okay, we need those 3 points on it. Again, remember if you're using colored pencil, you don't have to use the same color. You can just use another color. Just color code it the same. All right. And where, again, what's the most important point when I label this that has an exact location? The one in the middle, the vertex. Good. So what point has to be my vertex here? Good, J. Okay, and then it doesn't matter which one's T and which one's M. I read left to right, so I like to just do T, J, M. That's the way my brain naturally works. You could go the other way, though. All right, now I have this bisector. I have this part here. Is this a segment, a line, or a ray? Good. What told me that this was a ray, other than I said it a couple minutes ago? Good. It has one arrow. So where is our ray going to start? Starts at J, and then it's going to go through P. I don't have a P yet. That's the part we have to create. So remember, a bisect means exactly in the middle. So I'm going to try and think, if I had this connected, where would that middle be? Where would halfway be? So for me, I'm going to try and get it probably about here-ish, maybe. So I'm starting at that point J, and then I'm going to work my way out. I'm trying to make it so it's like halfway. So that ray starts at J, and then it goes through P. So that's P there. All right, how can I show my reader that that is a bisector? What do I now know about these smaller angles? If I had something cut it in two equal parts, we know that these two angles are now congruent. They're equal. So we can do those little arcs there. So we can do an arc on that first angle. I'm going to do two arcs just to show you what that looks like. So it kind of looks like a rainbow as we keep working our way out with all arcs. So you have two arcs there, and then I'm going to put two arcs on this next one. The arcs don't have to be in the same position or same place, but now when I see those two bands going across, I know that these now match. They're now the same. So if I knew that this whole thing, and when I do the whole thing, I kind of do like an overall arc. If I knew that whole thing was 120 degrees, how much would each of these angles be now? Good, 60. How did you get that? Cut it in half, yeah. What operation tells us to cut in half? If we needed to use a calculator. Good, divided by 2. So we could do 120 divided by 2, and then we get 60 and 60. So let's name just those congruent angles here. So because it bisects it, which angles now are the same? Who can name one of those smaller angles, one of those 60 degrees? Good. TJP is congruent. It's the same as PJM, or we could say MJP. Either one. It's your choice. I'm going to go with MJP just for fun. Switching it up on what my brain tells me to do. My brain would tell me PJM, but I'm going to go MJP. Either way. All right, we got one more big chunk of words to go through. These words most people already know. We're just going to make sure we have it written down. If you feel like you know these words and you don't need them, it's your choice. It's your notes. If you don't want to write them, you don't have to. It might just be nice. Sometimes when we're on doing a test or a quiz, which we don't do quizzes in here. I don't know why I said quiz. Sometimes when we do our test, our brain freezes up and we're like, oh, shoot, we know that word. So sometimes it's just helpful to have it written down in case you have that moment of like panic. Do any of you guys panic during tests? And your brain goes like blank? No, you guys are all great test takers. My brain always goes blank during tests. So, our next part is going to be to classify angles. So we have 4 main words to classify angles. We've already talked about one of them, and that's when we have a 90-degree angle. There's another word, though, when we have a 90-degree angle. What's that other word to describe 90 degrees? Good, a right angle. So we have a right angle, which means it's exactly 90 degrees. Okay, you can draw that there if you want, 90-degree angle. And we use that little square in the corner. That square tells us it's 90 degrees. right? When we have a small angle, we use that 90 degrees. So if it's smaller than 90, does anyone remember what we call that? Acute. If I was an angle, I would be acute angle because I'm little. Anyone? No? Cool. You're so cute, Miss Morrell. Aw, thanks. All right, acute is less than 90 degrees. Okay, so a way to identify an acute angle would be if it tells you the amount of degrees and it's a number smaller than 90. But in other ways, we use that idea of 90 degrees as kind of that L shape. So if I see anything that would be smaller than an L shape, where it's going straight out, we can usually assume that that's an acute angle. And smaller than 90, it's I'm taking that 90 degrees and I'm closing that door, I'm making it smaller. So if I have acute, what's our other word? Obtuse. And obtuse is more than 90 degrees. Okay, so it's like we're taking that 90-degree angle and then we're going to open that door more. So it's going to create this more open space. So it swings more than that 90 degrees. All right, we have one more, and this one might be one that you don't know or that maybe you do know but you just never thought of. And we call it a straight angle. Okay, and a straight angle means we're just doing a straight line or a line segment. And how many degrees is a line? Do you remember? 180. It's exactly 180 degrees. Now, if you move to another teacher later this year, some of you I noticed on your Skyward schedules, you might like switch between me or Miss Lundy or Mr. Varst. Some, if you switch to them and they're using, I think Miss Lundy uses Alex. Mr. Varst uses the textbook. I like to use Schoology. We all kind of do our homework different. But depending on what you're using, another word for straight you might see is opposite rays. I don't use it very often in this class because, I don't know, it feels excessive. But Alex definitely uses it, and so does the textbook. So if you're somebody who you move throughout the year, you might see that word opposite rays. That just means it's a line. Okay, so exactly 180 just means I have a straight line. There might be 3 points on it, or at least 1 point on it, but it's a straight line. All right, we're going to do one example, and we're going to draw this out. It's going to feel like, I know you're going to be like, what the heck, why didn't Miss Morrell just print this for us? So it's good for us to practice drawing angles. Eventually I'll print stuff out for you. Next week we have a lot of stuff printed out, which is great. Okay, so for our example here, if you want to write example, you can, or you just draw it, I don't know. You need probably about, I'd say like 10 lines at least. So if you're running out of room, maybe do it on the next page. Okay, we're going to start off with drawing a straight line, a couple lines down, a straight angle. Okay, we're going to label 3 points on it. Can't see back there. I don't, but I can give this to you at the end. Is that okay? Okay. All right. For this we have point W, T, and K. All right, and what we're going to do is from point T, we're going to go straight up. We're going to create a 90-degree angle there. And we're going to call that point X at the top. And I'm going to know that that is a 90-degree angle, so I'm going to put that little square in the corner there. That way I know it's 90 degrees. Okay, and then one other one, we're going to do one more. We're going to make an acute angle closer to K than to X. And that's going to be point M there. So double check that first. Make sure you got all of that. I know it feels like a lot. I know. So much drawing. That's why Mr. Tyson doesn't like to teach geometry, if you didn't know. He doesn't like to draw all this. All right, we're going to connect W and X with a segment to create kind of a triangle there. And then we're going to throw in some numbers for angle names. That way we could also use those numbers. So near the W, we're going to put a 1 on the inside of that angle. Near the X on the inside, we're going to do a 2. In this first part next to T, we're going to do a 3. And in that bottom part, we'll do a 4. All right, now we're done with that picture. Alright, so first thing we want to do is I want another name for angle 2. So one way to name angles is if there's numbers there, we can use those numbers. But if I want another name for it, what do I have to use? Points. How many points do I need? 3. Good. So if I look at this angle 2, I'm thinking about this 2 and how it is surrounded. So it goes from kind of here, it goes out. And then it also goes out from here. So we're looking at this angle near that top part there. That surrounds that 2. So it'd be a good time to use a highlighter. If you want to use a highlighter instead of colored pencil, you could. So what points do we have that create angle 2? How else could I say that? Good. W, X, T. Or what would be another way to name that? Good. T, X, W. Really important that vertex is that middle point. All right, if I want to know what is the vertex of angle 1, okay, so I'm switching it up here. I'm going to look at angle 1. So angle 1 now is that bottom corner. What's the point or what's the corner? Where does that angle come together at angle 1? What point? W. Awesome. And then let's just name 2 parts here. We're going to name an acute angle, which there's a lot to choose from. And we're going to name an obtuse angle. So if you want to look ahead, think, where could I find an acute angle? Where could I find an obtuse angle? And let's do straight also, I suppose. Straight would be a good one too. So which angle do you see is smaller than 90 degrees? MTK? Good, MTK. What's another way we could name MTK? KTM, or we could say angle 4, yeah. You guys are not about that lazy life. I'm about the lazy life. Just name it angle 4, call it good. But you could say TKM or, sorry, not TKM. You could say KTM or MTK. All right, now obtuse, we have to think a little differently because here, if I look at each of these as individual angles, each individual angle might not be obtuse. So I need to think of how can I get an angle that's bigger than 90 degrees. If I do TXW, that's not going to be bigger than 90. Yeah, I want to go to that TM, and where am I going to start?
It's going to be WM.
I'm going to do WTM, yeah. So angle W, I'm going to go to the T, and then I need to go past that 90 degrees. I need more than 90, so instead of going up to the 90, I'm going to go out to the M. Okay, if that's something that you need to show that, you want to highlight it, you can grab a highlighter or a colored pencil. W, T, and then M. So when we look at these pictures, we're not always looking at them as like the small little angles. We can combine those angles into anything to make a bigger angle. All right, and then straight is just a little goofy. For some reason, it gets people confused. Straight, we just use the word we put that symbol angle. And then we're just naming the 3 points that make that straight line. WTK or KTW. Yep, either one.